Now that we've learned all these arithmetic operations with positive and negative numbers, we have all these rules at our disposal, let's actually combine them in different problems. Here's an example. I have 2 plus 3 times 4 equals what? Well, there's a little bit of a problem with this, because should we put the 2 and the 3 together? Should we add them up first? Or should we multiply the 3 and the 4 together first? Okay, so there's some ambiguity here unless we lay down some more rules. And these rules are called the order of operations, and that's what we're going to be covering next. Now, the first thing before we actually even really dig deep into order of operations is we need to discuss what are called grouping symbols. To learn more about grouping symbols, let's actually do an example. I have 1 minus 2 plus 3. I would like to perform the operation with the 2 and the 3 first. So to illustrate that, I'm going to use parentheses. So I'm just going to surround these two. That means do 2 plus 3 first, and then when you get that answer, go 1 minus the result. So now I want to incorporate some more stuff to this problem. So I want to multiply this, let's say this whole thing by 4. So I'll put a 4 right here. And I'm going to now throw in a new grouping symbol, which is the square bracket, or just the bracket. Now notice I didn't put a multiplication symbol. This is implied multiplication when there's nothing between the 4 and the symbol. Okay. Now the next thing I'm going to do is I'm going to say 5 minus this whole thing. How about grouping symbols? Well, actually we don't need any at this point. Okay. We're going to learn very soon that when we have additions or subtractions joined with multiplications or divisions, multiplication and division are done beforehand. So this will be done first automatically, then this. Now if I want this done first, I would of course use all the grouping symbols, but in this case then. Let's go up another notch. So now I want to have 6, and I want to add that to this entire problem right here. So another grouping symbol are curly braces, or just braces. So let's throw in a couple of those. One here. And I'm going to group this whole thing together like that. So 6 plus this whole thing is what I want to do next. And now you say, why stop there, right? Let's just keep going. This is just so much fun. Okay, sorry, I got a little excited there. You might as well throw in a 7. So I'm going to go 7 minus this whole thing. Well, now what type of grouping symbol should we use? Well, we could throw in other parentheses or square brackets or braces, but there's one more all-encompassing symbol, and that's a bar, like a horizontal bar. It's also called a vinculum, or vinculum. Not sure how it's pronounced, but bar is fine. And I'm going to encompass this whole thing. There we go. So this bar represents all this is one entire group. So it's 7 minus the group of items. And those are the main grouping symbols that we'll be operating with. Now, a little bit overkill here with this problem, obviously, but I just want to illustrate everything in one fell swoop. Now, if you were doing something like this on the calculator, the only grouping symbols you're allowed to use when you're dealing with numbers like this are parentheses. Yes, the calculator has square brackets and braces, but they're used for other things. So I know you might see them on a calculator. They're right on this. They're right on here. Don't use them unless you know what they're for. Okay. Now let's take a moment to look at other grouping symbols. Let's take a look at some other examples of grouping symbols. First off, a fraction bar is used to encompass everything that's in the numerators on top and everything in the denominator is on the bottom, and they're enclosed together. Implicitly, it's implied by the fraction bar. Another symbol that's used is the absolute value notation, the vertical bars. So here, I'm grouping together the x plus 3. Finally, the radical dude, just the radicals are used to encompass items. See here, the 3 minus y is enclosed inside the radical symbol. Another way of writing all our different grouping symbols is as follows. So let's say we're given this thing on top we have our parentheses, and then we have our square brackets, we have our braces, and we have our horizontal bar. Looks kind of nasty looking. So another way of rewriting it is to alternate the parentheses and square brackets. See how I did that? So I started with the parentheses in the innermost set of grouping symbols, then I move to the square brackets, then I go to parentheses again, and then finally I go with another set of brackets. And see, this one, yeah, it's still a rather complicated problem, but it is a little bit more soothing to the eyes, I can say. There's nothing special about parentheses. If I want to group items together, I can use parentheses, but no, I can use other things too. For example, you can just use the square brackets, and that's fine. Okay? Traditionally, we use parentheses, and then if we have parentheses and we need to use other grouping symbols, then we throw in the brackets. But you don't have to do that. You can use square brackets to begin with. And why just do square brackets? Right? We could also use braces to encompass items together. And finally, if you want, you can just use the horizontal bar like this. So you have 1 plus the group of 8 minus 3. But just stick with parentheses. It's probably easier for everybody. The first rule of order of operations is to evaluate any expression within grouping symbols. So in this case, I would evaluate 8 minus 3 first. Now, if you have grouping symbols within grouping symbols, like in the second example here, you perform the operations within the innermost group of symbols first. So in this case, the 1 plus 2 is done first, and then you work your way out. Now, I won't take time to actually finish these problems right now, but later on we will do quite a number of examples of this. The second rule of order operations is perform anything that has an exponent first. So something like this, I will not add the 3 plus 4 first. The rule is, if you see an exponent, that's evaluated first. So I would actually say 4 squared, then add 3 to that. The next rule is you perform all multiplications and divisions next, in order from left to right. So something like this, I would perform, so here we have a couple of things we can do. We have a multiplication here, and we have a division here. So those will be done before we do addition. Okay? And since we're supposed to go from left to right, I will perform this operation first. So let's actually do this problem. So 3 times 2 is 6. I'm going to just copy down the rest. Next, order of operations says we should need to do divisions before we do additions. So I'm going to perform this operation next. So the 6 stays. 4 divided by 2 is 2. And I will do the 6 plus 2. There's my answer. The last rule we need to do is we perform all additions or subtractions from order from left to right. So here we have something that has just additions and subtractions in them, and we go from left to right. So we're going to do this operation first. So 8 minus 3 is 5. I'm just going to copy down the rest. Again, I only have additions and subtractions, so I go from left to right. So 5 plus 5, I'm going to do that operation. I'm going to get 10. Now I do the subtraction. 10 minus 1, the answer is 9. Order of operations. First, evaluate the expression within the innermost set of grouping symbols. Next, evaluate expressions that have exponents. Then, perform all multiplications and divisions, going from left to right in the expression. Finally, do all additions and subtractions, again going from left to right in the expression. Now, I did actually memorize the operations, and it may seem a little complicated, but there's a very easy way to remember everything. I'm going to use this acronym, PEMDAS. What does it stand for? Well, it's very easy. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now, the word PEMDAS doesn't really sound like anything, like another typical word. So there's another mnemonic device or memory device to help us remember the word or acronym PEMDAS, and it's the following. Please excuse my dear Aunt Sally. There she is. Hi, Aunt Sally. Sorry. So that's a very easy way to remember it. So please excuse my dear Aunt Sally, PEMDAS, parentheses, exponents, multiplications, divisions, additions, subtractions. Another way of thinking about order of operations is using the terminology order of precedence. Precedence just means how important something is, what's the priority. And you can see that here in this illustration here. Again, here's PEMDAS once again, and the higher the operation, the higher the precedence. It's important. So the highest precedence is using grouping symbols, parentheses, brackets, and so on. Next is exponents. Now again, not necessarily square, that's just for illustration purposes. And then you have multiplications and divisions. Now again, just because multiplication is mentioned first doesn't mean it has to be done first. It's a tie. So it's just whichever goes from left to right, what's on the left is done first, and then so on to the right. And the lowest order of precedence is addition, and you also have subtraction. And again, it doesn't matter which one you do first, as long as you go from left to right. Another thing I wanted to let you know that most graphing calculators understand this order of precedence. This one does, and it matches this. Now, if you have other types of calculators, little scientific calculators, non-graphing models, they may not necessarily follow this order of precedence. So you will need to consult your calculator manual for that. Let's do some examples now on using these order of operations. For the first one, we want to simplify this expression right here. So let's follow our rules for PEMDAS here. So parentheses, now I don't have any grouping symbols. So exponents right here. So I'm going to do that first. So anything I don't manipulate, I'm just going to write it over again. So this is equal to 4 plus 3 squared is 9 times 2 minus 10. Now continuing our order of precedence here in PEMDAS, multiplications and divisions are next, going from left to right. And we have a multiplication right here. So the 4 stays, 9 times 2, 18, and we copy down to 10. Continue going. Now I only have addition and subtractions left. So you go from the order from left to right. 4 plus 18 is 22, and we copy down to 10. And our last step is combining these two terms. 22 minus 10 is 12. And that is our answer. Let's now try that using the calculator. Simplify 4 plus 3 squared times 2 minus 10. First step is to input the expression. So clear? 4 plus 3, press the square key, times 2 minus 10, and then enter. And the answer is 12. Let's now simplify this expression. It's a little more complicated, but I think we can handle it. Again, the key thing is to do things step by step. So I'm going to want to scan this and say, okay, what's my parentheses? Okay, I have a couple of sets right here. So the rule is you do the innermost set of parentheses. So everything else just gets rewritten over again. So I'm going to get negative 5 plus 2, 3 minus 4 times the quantity. Well, 7 minus 6 is 1. And everything else just stays the same. I want to simplify this further. So I only have one set of parentheses, so we do what's in the inside. So when you do what's in the inside, what's the order of precedence now? Well, I have something that's raised to an exponent, so I need to do the 2 squared. Everything else stays the same. So I get 3 minus 4 times 1 plus 2 squared is 4. Let's keep going. So again, we're still in the inner group, this group of parentheses, and there's a multiplication. Think of this as negative 4 times 1. So everything else stays the same. So I'm going to get 3. Negative 4 times 1 is negative 4. So I'm going to write that down. And I still need to continue doing this, so I have just addition and subtractions, so I take care of those. And you go from left to right. 3 minus 4 is a negative 1. And everything else stays the same. So I get -1. Now let's perform this operation. -1 plus 4 is 3. Now, looking at this expression, I have -5, and it's being added to the quantity 2 times 3. So order precedence here is I need to do multiplication before I do any additions or subtractions. So 2 times 3 is done next. So this is equal to -5 plus 6. And finally, I can barely squeeze that in there. -5 plus 6 is 1. And that is my final answer. Clear? -5 plus 2, open parentheses, 3 minus 4, open parentheses again, 7 minus 6, close parentheses, plus 2, press the square key, close parentheses, and finally enter. And the answer is 1. For example 14, we have another expression we want to simplify. Let's go through the steps again. I need to do the grouping symbols first. In this case, the absolute value are considered our grouping symbols. We need to do everything inside absolute values first. And within here, I have a subtraction and multiplication. So according to this, multiplications have high order precedence. They're done beforehand. Everything else, I'm just going to write it over again. So it's 2 cubed minus the absolute value of the quantity. 5 minus 2 times 8 is 16. And then close the absolute value symbols. We saw the grouping symbols, so we have to now evaluate 5 minus 16. And everything else stays the same. So you're going to get -11. Now they're still within grouping symbols, so we still have to evaluate this part. So again, this part stays the same, so I'm going to write that over again. Absolute value of -11 is 11. So now I write down 11. So you need to be careful. You have to first copy this part down, so the negative stays. And then I'm evaluating this part. So now that gives you the positive 11. A lot of people make a mistake and make that a plus 11. Don't go there. And then according to this, I have to do the exponents. 2 cubed is 8. And finally, 8 minus 11 is -3. And there's our final answer. Simplify. Clear. 2 power 3 minus, now I want the absolute value, so I press the second function key, and then I want catalog. Once you press enter, that gives you the absolute value. Now continue the expression. 5 minus 2 times 8, close parentheses, and enter. And our answer is -3. For our last example, we're given a fraction. And the basic strategy for doing a fraction is as follows. You want to try to evaluate the entire numerator, then you try to evaluate the entire denominator, and then divide numerator by the denominator. And I go through that in meticulous steps in the notes. But for the video, what I'm going to do is actually show you an alternate procedure. What you want to do is, if you can, try to simplify things tops and bottoms at the same time to minimize your writing. But again, if that doesn't feel right, then do what I just said. Do the entire numerator, get a value, entire denominator, get a value, and then divide the two. But we'll do it the faster way. Let's go ahead and take care of that right now. Let's go ahead and get started with this problem. So trying to simplify the numerator following PEMDAS is I don't have grouping symbols, but I have exponents. So 5 squared is 25 minus 3 cubed is 3 times 3 times 3, which is 27. And then the 4 just stays all by its lonesome. The denominator, I'm going to do grouping symbols first. So everything else stays the same. It was 8 minus 5 minus 3 is 2, and it's being squared. Let's keep going. On the top, we only have additions and subtractions, so you go from order from left to right. So 25 minus 27 is negative 2, and the 4 stays the same. In the denominator, order of precedence, I have to do the exponents next. So it's going to be 8 minus 4. And it's getting really simple here. Let's just keep going here. Negative 2 plus 4 is 2. 8 minus 4 is 4. And finally, we can reduce this fraction. 2 divided by 4 is a half. And we're done. If you want to simplify this expression, your first step is to change it into this one. Make sure you encompass the entire numerator within a set of parentheses and the entire denominator within an extra set of parentheses. Now let's input this in the calculator. Clear? Let's put the top part first. Open parentheses, 5 squared minus 3 power 3 plus 4 close parentheses. Now let's divide that, so press the division key. Let's input the denominator. Open parentheses, 8 minus, open parentheses again, 5 minus 3, close parentheses, and square it, close parentheses, and enter. The answer is 0.5. And to make it official, let's just convert this into a fraction. So press your math key, and then enter, enter again. There's your half.